Hi everyone. In this video, we will continue along our study of rational functions and actually break down the steps for using which the graph of such functions can be drawn. So we saw in a previous video that although we get these asymptotes, there are some possibilities which we have to consider, which means we don't have enough information. Okay, so to get enough information, we follow this sort of 6-step process, which is factor. So in this, we are going to factor both numerator and the denominator. Then we're going to find the intercept, right? To find the y-intercept, we set x equals 0, and to find the x-intercept, we set the numerator equals to 0. Now, if you've done the factoring already, then this setting the numerator to 0 is going to give you the intercept directly. Vertical asymptote is we set the denominator to be 0. Horizontal asymptote is we use the rule from previous video. So that is, you look at the highest power terms in the numerator and denominator, and then you directly divide their coefficients. Plus minus values is you set the numerator equal to 0, the denominator equal to 0, and find the sign of the rational function in each interval. Okay, we will go over what that means and how to do that. And lastly is sketch. When you sketch, you make sure that all the conditions of 1 through 5 are satisfied. Okay, so let's follow the process. Factor. I'm going to use split the middle term to factor. So I'm looking for two numbers with a product of -8, sum of 7. The only possible way to do that is 8x minus x. Factor out a 2x to get x plus 4, -1 for an x plus 4, which eventually comes out to 2x minus 1 and x plus 4. Now I take the denominator and I do the same thing. Very little possibilities here. Multiplication -2, it can only be 2 and 1. So that becomes an x plus 2 minus 1 x plus 2. Then that becomes an x minus 1 and an x plus 2. Okay, so that gives us the factors. The second one is intercept. So x-intercept, let's do that first. Oops, not x-axis. X-intercept is, what does it say? It's basically when the function is 0, which means you set the numerator to be 0. So you have 2x minus 1, x plus 4 equals 0, which gives you x is 1/2 and x is -4. So you have two x-intercepts. What about y-intercept? Is you said x equals 0, right? So you have 2 times 0 plus 7 times 0 minus 4 over 0 plus 0 minus 2. Right? So that's going to be -4 over -2, which is 2. Now let's find the asymptotes. So vertical asymptote. Vertical asymptote is denominator equal to 0. So x minus 1, x plus 2 equal to 0 gives me x is 1 and x is -2. Horizontal asymptote, well, just look at the ratio. 2 over 1, so that is 2. How do we write this? This is y equals 2, right? Because it's a horizontal line. Now the fifth one is new, plus minus values. So what we do is, it says plus minus values. We set numerator equal to 0 and denominator equal to 0. But we've already done that, right? So that gives me x is 1/2, x is -4, x is 1, x is -2. Now what I'm going to do now is I'm going to plot these points on the number line. Right, so I have -4, -2, 1/2, 1. When I plot these points, I have these distinct intervals: 1, 2, 3, 4, and 5. I'm going to pick some point in each of these. Right? So here, let's say I pick -5. Some number between -4 and -2 is -3. A number between -2 and half is 0. A number between half and 1 is 3/4. And a number more than 3 is 2. Okay. Now this is the process that you kind of learned in what was that called? Rational inequalities, right? We're trying to find where is this function positive and where is it negative. So to do that, the quick way to do that is you notice that in the factored form there is no repeated roots, right? So there is no squaring, which means it's going to be alternating between positive and negative. So all you have to do is check at 0. Now at 0 you've already checked, right? At 0, if x is 0, y is -2. Oh, sorry, +2. So it's positive here. Since we already know that it's positive here, it means it's negative here, and then positive here, and negative here, and positive here. But be careful that this only works if there's no repetition of roots, right? There's no squaring involved. Okay, so once you have that, now we have everything we need to plot this function. So let's go ahead and do that. Let me still use purple. Okay, now starting up top, factoring gives me nothing. Intercept, x equals 1/2 and x equals -4. So the graph goes through these points. Y-intercept 2, the graph goes through that point. Vertical asymptote at 1 and -2. So 1, an asymptote at 1, an asymptote at -2. So I have x equals 1, x equals -2. Horizontal asymptote at y equals 2, which is also the y-intercept. All right, what else do we know? We know, let's see, this point is x equals -4, and this is x equals 1/2. Right, we know that it's supposed to be positive here, right? Positive here. And while it is positive here, it cannot go beyond the 2. So that's what's going to happen. That's positive. After -4 and to -2, it is negative. So it goes down, but that's a vertical asymptote. After between -2 and half, it is positive, but this is a vertical asymptote. So it's got to come down from here, but it's got to go through the, what's that? The y-intercept. And then it's got to go through the x-intercept, and it's got to go down on the vertical asymptote. After 1, it's positive. It's positive, but this is a horizontal asymptote, so it cannot cross that line. Okay, so remember, the horizontal asymptote is the behavior as x goes to infinity and as x goes to -infinity. And that's why it's not a contradiction that this graph crosses that line in the middle, right? Because this is x equals 0, that's an intercept. It's not the place where the asymptotic behavior for horizontal is in infinity and -infinity as the input becomes large. It's not at any input, right? So you can have points going through that, right? You can have inverse at that point, but yeah, it's so just be careful about that. Not to, if you're thinking about, well, why is this crossing here? Well, that's because that's not what the horizontal asymptote definition says. The horizontal asymptote definition only deals with the case when the input is infinity or negative infinity. Okay, so that's typically how this is done, so that we get the graph. That's gonna be it for this video. Next video we are going to consider a couple of special cases and an application, just so that you know what possible errors that might happen while doing these kind of problems. That's it for this video. Thank you.